Hey everyone! Today we are solving a question on how to find the volume of a solid of revolution. We have a region bounded by a curve and a line, and we are going to spin it 360 degrees around the x-axis. It looks complex because the top function changes halfway through, but we are going to break it down into two simple steps. Let's start. First, we need to know where our functions cross. We set 3x squared equal to 3. Dividing by 3, we get x squared equal 1, so they intersect at x equal 1. Because we are looking at the interval from x equals 0 to x equal 2, this intersection point splits our problem into two distinct parts. Part 1. From 0 to 1, the line y equal 3 is on top. Part 2. From 1 to 2, the curve y equal 3, x squared is on top. To find the total volume, we'll calculate the volume of each part separately and add them together. For the first section, our outer radius, big R, is the line y equal 3, and our inner radius, small r, is the curve y equal 3x squared. Let's plug those into the washer method formula. Volume 1 equals pi times the integral from 0 to 1 of 3 squared minus 3x squared, all squared, dx. Simplify the integral, we get volume 1 equals pi times the integral from 0 to 1 of 9 minus 9x to the fourth power, dx. Now we are ready to integrate the terms. Term 1, 9 becomes 9x. Term 2, 9x to the fourth power becomes 9 over 5x to the fifth power. So our integral is volume 1 equals pi times the quantity 9x minus 9 over 5x to the fifth power, all to be evaluated from 0 to 1. Evaluating x equals 0 will end with a result of 0, since both terms have an x value. So let's concentrate on our upper limit for part 1. For the upper limit, x equal 1, we get 9 times 1 minus 9 over 5 times 1 to the fifth power equals 36 over 5 pi. So volume 1 equals 36 over 5 pi. Now for the second half. Between x equal 1 and x equal 2, the parabola y equal 3x squared is now further from the x-axis, making it the outer radius. The line y equal 3 is now the inner radius. Volume 2 equals pi times the integral from 1 to 2 of the quantity, 3x squared, all squared, minus the quantity 3 squared, dx. Notice it's just the reverse of the first one. Simplifying the integral, we get volume 2 equals pi times the integral from 1 to 2 of the quantity, 9x to the fourth power, minus 9 dx. Let's integrate our terms now. Term 1, 9x to the fourth power becomes 9 over 5x to the fifth power. Term 2, 9 becomes 9x. Therefore, our integral is volume 2 equals pi times the quantity, 9 over 5x to the fifth power, minus 9x, all to be evaluated from 1 to 2. Let's start with the upper limit, 2. When x equals 2, 9 over 5 times 2 to the fifth power, minus 9 times 2 equals 198 over 5. For the lower limit, x equals 1, 9 over 5 times 1 to the fifth power, minus 9 times 1 equals negative 36 over 5. Subtract the lower from the upper limit. 198 over 5 minus negative 36 over 5 equals 234 over 5 pi. The finish line is in sight. To get the total volume, we just add volume 1 and volume 2. Total volume equals 36 over 5 pi plus 234 over 5 pi equals 270 over 5 pi. Now just divide 270 by 5 and we get 54 pi cubic units. The most important takeaway? Always check if your functions cross within your interval. If you do, split that integral up. If this step-by-step breakdown helped you make sense of the washer method, hit that like and subscribe button for more math tutorials.